Hi everyone. We are going to go ahead and go over the last question in our third assignment. To clarify, our first assignment was following that Instagram account. Second assignment was the first Google form, which was about solutions and concentration. And now this is our third assignment, which is molarity calculations. So molarity is synonym of concentration. And so when we're going to talk about the concentration of a solution, we're talking about how many particles of a certain substance are in a specific volume of a liquid. So usually we dissolve some sort of solid like salt or sugar or any sort of what we call ionic compound into water. And this is going to create a solution. And so when we talk about these solutions, the concentration is going to be represented by this uppercase M that we see here, which indicates molarity. Okay, so molarity similar to concentration. And what this means is we're now going to figure out if we have a certain volume of this concentration, what happens if I dilute the solution or make it less concentrated to this concentration. So if I'm decreasing my concentration, what's going to happen to my volume? So what we're going to see here is we're going to use the calculation M1V1, so multiplying our concentration times our volume to get our final concentration and volume. And if we take a look at the other equation which we are given, which is that our concentration is the moles of our solute, or whatever we're dissolving, in liters of solvent, which is whatever we're dissolving it in, so usually water. If we look at this other equation, notice that we can actually take our concentration and multiply it times our volume to get moles. If we rearrange this equation, we rearrange it to just have moles as one of the sides of the equation, we're going to have our concentration times our liters, and another thing we can put in there for liters is our volume. So concentration, molarity, times volume is going to equal the number of moles. And so ideally here we can take a look at that and say, okay, if I know M times V is moles, M times V is right here, so our initial M times V has to equal our final M times V. In other words, we have to conserve the number of moles that we started out with and the number of moles that we're ending up with. This is a classic conservation of matter, where we're conserving energy, conserving matter, conserving particles. Okay, so now let's get into the problem. Let's go ahead and underline what we know. So anytime we see any important piece of information, we're going to underline it. Milliliters we know is a volume, so we're going to go ahead and label that as our V1, our initial volume, and we have this initial concentration as well. So when we read this as 0.36 molar. Okay, 0.36 molar. This molar word is what we're going to use to identify concentration, or the units of molarity. Okay, so it's going to be moles per liter. So here we're going to say this is going to be our M1. So we have this volume of this concentration. We've got M1 and V1. Now what we're going to do is take a look at our other piece of information that we're given. That's our final piece of information that we're given once we've diluted that solution. So if you dilute the solution to a smaller concentration than what you started with, so this is our second concentration, our second molarity, what is the final volume? We don't know what that final volume is, so we're going to go ahead and circle that. And now we've both annotated for our given information and circled what we don't know. So what we can do is go ahead and plug this into our equation that we have boxed at the top. However, we have to change our milliliters to liters first. So what I'm going to do is I'm going to take my 500 milliliters. Notice that we have a decimal point here, which indicates that this is 3 significant figures. And we're going to take this decimal point, we're going to move it to the left 3 times. It's the same idea as dividing by 1,000. That's going to get us from milliliters to liters. So we go 1, 2, 3. That means that our answer here for milliliters to liters is this is half of a liter, 0.5 liters. Okay, and that's our V1. Now let's go ahead and plug these all into our equation. So our first step, write your equation down. Always write that equation down first. Second step is now to plug those values in. So we're going to take our M1 and our V1. Remember, you're not plugging in the milliliters value, you're plugging in the liters value. Our M2 is right here in our problem. So we're going to take our 0.14, and we don't know V2. Now let's pause for a second and talk about why we converted from milliliters to liters. So it's important that we always have our volume in liters, and the reason behind that is if we look at this first equation up here, anytime you're talking about concentration, it's moles per liter of solution. Okay, moles per liter, not moles per milliliter, moles per liter. So in order to multiply times a concentration, we need to abide by the rule that our volume is always going to be in liters so that we're not comparing units that are not able to be compared. Okay, so we have to convert to liters. Similarly, how we converted to Kelvin in our gases unit. Always convert from degrees Celsius to Kelvin. Here, we're always going to convert from milliliters to liters. Okay, so now that we've got our 3 values in and we're looking for our unknown, we can go ahead and multiply these two. So if we take our calculator, I'm going to get 0.36 times 0.5. 0.18 is equal to 0.14 V2. Now we can go ahead and isolate V2. So we're going to divide both sides by 0.14. It's going to eliminate this side of the equation. And we can do that on our calculator. And we're going to get this number with a long decimal. So I'm just going to write out a few of those decimal points, blah, blah, blah. Now let's take a look at the sig figs we need. So looking back at our original problem, we have 3 sig figs in this number because of that decimal point. We have 2 sig figs in this number and 2 sig figs in this number. So our answer can only have 2 sig figs. So our answer is going to have 2 sig figs, 1.3. Make sure you round this up. And our final units, we now need to figure out. Well, the good thing is we kept our variable for V, and we know that volume has to be in liters. So we just put a nice liters units on there, box that final answer. Now let's take a look. If we look back at the problem, we started with half a liter of this solution, and we diluted it, meaning that our concentration decreased, so our volume had to increase. That's a reminder and review from our lesson last week. So if our concentration has to decrease, we know that 0.36 is bigger than 0.14, so our concentration is decreasing, that means our volume should be increasing. And what's good is we have our initial volume, 0.5, started with 0.5 liters. We ended up with a bigger volume, which is 1.3 liters. So that checks out. I saw a few people in their homework answering with this number or this number. Okay, the issue with this is that you have the correct calculation, but you didn't put it in the proper sig figs. So let's make sure we're paying attention to sig figs when we're entering our numbers on the Google Forms. I also saw a few answers that were like this. This value tells me that you did all of the calculations correctly and you did your significant figures correctly. However, you did not convert from milliliters to liters. Okay, so that tells me that you got that answer, that 1.3. However, you had it in milliliters, not in liters. So let's make sure this would mean milliliters. That would be correct. And you then need to convert it to liters and divide by 1,000 or move the decimal place 3 times. All right, that just about sums up the molarity calculations for dilutions. Please make sure you are reaching out to me if you have any questions.